Here's an introduction to experiment 12 on gas laws. So here we're looking at what's called the kinetic molecular theory and the relationships between volume, temperature, and pressure for gases. So here when it asks you in the lab manual about the different principles of the kinetic molecular theory, this is where you would want to look. And they're the assumptions about an ideal gas. The videos will show you procedures A and B. Part C just has data already provided for you. So here you'll complete the pre-lab. When you get to part A, this data will be provided in the video and it'll be a graph. So what we've done is we have taken a syringe with air and we have changed its volume. So we've compressed it and we have expanded it, and we have recorded the pressures at each of those volumes. So what you'll notice is you'll be able to take from the graph and figure out what the pressure was when the volume was 7 milliliters, what the pressure was when the volume was 8, etc. And there will be some of these that have repeated measurements. So you'll want to average all of the 8 milliliters, for example, and average all the 9 milliliters to get their average pressure. And then you will make a graph using part A's data. So if I scoot back here for a second, one thing you'll want to make sure you don't miss is this right here, where you're going to be making two graphs, one based on part A data that I just talked about, and one based on part B data. And it tells you to put the pressure on the y-axis and the volume on the x-axis. So part A lays that out for you there. And then part B, what we'll see here in a second, is you'll use pressure versus temperature and you'll draw a graph. For part B, once again, this information will come from the video and a graph will be provided. And so the video will give you the temperatures and the pressures. And what you'll need to do is convert the Celsius to Kelvin. And then you'll end up graphing your temperatures and your pressure relationship, as the lab manual asked you to do. Part C, the data is already in your lab manual. So here what you're doing is you're actually calculating R. We know that R has a value of 0.0821 liters, atmospheres over mole Kelvin. But what we're doing is here you would have taken carbon dioxide and allowed it to sublime and then measured the pressure that was produced. So here one thing that's helpful to know is that dry ice is CO2. That's its formula. So here we're trying to get to where we can use PV inert, right? So the equation PV equals nRT, because what we're going to try to find is R. So up here, given this data, we're looking for P, V, N, and T. So what you'll notice is here, change in pressure, this is going to be your P value. But what you need to do is change that to atmospheres before you can plug it into PV inert. Your temperature is given here in Celsius, so you'll convert it to Kelvin, and that'll be your T value. So you already know P and you know T. Your volume is given here as the volume of the gas. It's already in liters, so it's ready to go. And then the N value for moles, what you'll need to do is look at these two masses here. Here's the dry ice that was in the flask to begin with, some of which sublimed, and the dry ice that remained is down here. So what you'll have to do is subtract these two values to figure out how much dry ice actually sublimed and created any pressure. So you'll subtract the 37 value minus the 36. This will give you grams, and you'll have to convert it to your moles using the molar mass of CO2. And then you now know P, T, V, and N. So you'll actually set up this equation that's shown down here. The R equals PV over NT. That'll give you a calculated R value. And then for percent difference, you use this guy here, where actual is what you know to be true, the 0.0821, minus your experimental, which you just calculated, over the actual again times 100, and that'll give you your percent difference. Once again, you'll remember to do the graphs for parts A and B, and then you'll answer the post-lab questions.